Disco Ladyada.
Hey everybody, it's me, Ladyada, at my desk. Happy weekend. We got a whole bunch of hardware done. We're going to follow up on last week's videos where we talked about our Feather RP2040 series. So last week we did the RFM 69 and the DVI Feather. And the DVI Feather is actually going to be in the shop really soon, which is cool because people can do all sorts of video projects. And then we got some more prototypes this week. So let's show what the put together prototypes look like under the overhead. So first up is, hold on, this is a e-ink feather. So it's got the RP2040 bones over here, the RP2040 chip, LiPo battery and battery charging, USB-C reset and boot buttons, STEM QT connector, and then over here is a 24-pin connector and some power supply stuff. You can see like a little inductor and some transistors and capacitors and stuff to support driving e-ink displays. And we have a bunch of e-ink displays stocked. The small is 1.54 inch up to, they make them huge. They make them up to 7 inches or more. This is a 7-color e-ink display. It's called an ASEP display. And so you can see there's like red, blue, dark blue, white, and there's also black over here. So this doesn't even show all the colors, but this is a 7-color e-ink, and this is also supported. One of the things about e-ink displays, because I've first off, they're quite a thing. I don't recommend writing drivers for them. I've written like dozens of drivers, and they're all very similar, but if you don't get the driver perfectly right, they don't respond because the commands are slightly different from chipset to chipset, and the chipsets change constantly. So this one is a tricolor. So you can see there's a red layer and a black layer, and white is just like the absence of any layers. Even though it's like a 2-layer, it's called a tricolor. So whatever, because white is always like one color. And these displays, like this one, I think is, oh man, I can't remember. It's like 250 by 120 or something pixels. And it's 1 bit per pixel per layer. And each layer is like considered its own frame buffer. And they do end up needing a lot of RAM. Like if you do the math, like for example, let me just quickly pull up the part number so I can tell you what this is. This is the 2.13 inch tricolor. Oops, sorry. Tricolor. Sorry, it's 250 by 122. So you do the math. 250 times 122 is 30,500 pixels, and there's 8 pixels per byte. So you need basically like 4K of RAM for each layer that you have of this display. So together it's 8K. And, basically you can use an external SRAM chip, and we've done that for some of our feather wings, but it's much, much faster if you can just buffer the whole display in the chip RAM. But 8K is like, if you have a Arduino Atmega 328, only has 2K of RAM. And so an RP2040 is a great chip for this, because one of the cool things about the RP2040 is it has 264K of RAM, so it can easily buffer this entire display and draw it. And of course, it's e-ink, so after you're done playing with it, you disconnect it. And even though the RP2040 isn't designed for low power, it does do a fair job. And I'm going to test out just making sure, like, what is the power draw. So I'll do that before ordering this board, just in case I made a mistake. So that's the e-ink feather. And I kind of pulled the connector back. You can see that I wanted to make it so that the mounting holes were still usable. So like it's kind of positioned it so the flex connector is not in the way of the holes. So this e-ink feather, I'm going to do a couple more power tests, but it does work quite well. And it works with our Adafruit EPD Think Ink library, and we have drivers for all sorts of chipsets in there. And then the other feather that we got, the RP2040 feather, because we've been designing a whole bunch, carefully put the e-ink stuff away, is this one's very exciting. So this is USB host. Sorry, one second. This one is USB host feather. So again, RP2040, same circuitry. And you'll notice, one of the nice things about the bones design is that, this part is all the same, and then we just change around, what's on the end there. So instead of the e-ink, this one has a surface mount USB-A connector. On a previous great search, we showed how to get this connector, and it just makes it easier, less through-hole soldering, and also makes the bottom nice and flat. And then over here, this is a TPS 61023, which is a 1 amp 5 volt boost 5-volt boost converter, and that's great because even though this is connected through USB and this gives you 5 volts, maybe you want to run this off of a LiPo battery. So let me find my battery. Hold on, it was here. Oh, one moment. Where did it go? I had a little power monitor, but it's black and everything on my desk is black, so I'm not going to find it. But you can connect a little power monitor to here, and I just verified that it gives you 5 volts output, and then I even charged a phone through it to make sure that I could get half an amp, which is the USB spec. And then even down here, you can see that the little 5-volt fuse, it even says 5 on it. So that gives you 500 milliamps at 5 volts. And this is great because, you can turn on and off. It's very important, I found, that when you're doing USB host stuff, to be able to turn on and off the USB power. So the enable pin is like a true shut off. So that will completely depower the 5 volts. So that kind of gives you a fresh start, especially when like you have chips that are kind of like not enumerating cleanly. You can start it with it powered off, turn it on, and then wait for the enumeration. And so here's an example of an HID device. So this now works with Teeny USB, and we have what I like is, of course, you could do USB host through the main USB port, but then it's really hard to debug. So what I like about having the USB host be separate is now you have debugging and programming through here and your peripherals through there. So let's plug in this SNES-like joypad, and then let's go to the computer. And I'm running this example that does an HID report, and what I do configure is just tell it, which is the data plus pin, and then data minus is always one pin after that. That's how it's done the PIO. And then the enable pin, again, to enable the VBus. And then you just have the USB host code. We wait until the serial port's open, and then the second core is where it does the USB host stuff. There's a couple of requirements, like you have to be running at 120 megahertz, or 240, which is overclocking, because that gives you a nice clean divisor into the 12 megahertz. Probably could eventually be tweaked, so it didn't have to be so specific, but it's such not a big deal to compile it with that frequency. And then what this does is it, on mount, on when the device is plugged in, it says, hey, here's the VID and PID, so it detects what device is plugged in. And then it listens for HID reports. So HID, human interface device, is a USB standard for keyboards and mice. And like it basically what allows you to have a USB keyboard work with any computer. Like mass storage, it's very, it's like universal. And this joystick is also an HID device. So I think I have the right COM port. So now, well, let me reset just to make sure. And then I have like a bazillion COM ports. I want 13. Okay. So it's streaming out the HID report. I think if I go to the top, whoop, yeah, so it boots up and it says, plug in a thing. And now, as I press the buttons on this little joystick, you'll see the data changes. So it's like 1F, 0F, 8F, different buttons connect to different parts of the HID report. And like I said, keyboards and mice are standard. I think this is probably a generic joystick. But this is useful for HID remapping. So a couple projects that we thought would be neat to do is, one is this idea of an anti-shake mice. So if you have an essential tremor, or you have like Parkinson's and you shake uncontrollably, it can be very hard to use a mouse. And like the harder you concentrate, the harder it is. And so your mouth shakes back and forth. Well, that's like, if you have an HID remapper, you can read that mouse movement data, apply a low pass filter. So instead of it shaking around a lot, it, slowly moves, but it moves in the average of like the last 20 data points. So that's kind of a cool project that you can do with HID remapping. And another project you can do is get an IntelliKeys working. So this is an IntelliKey. Maybe we can go to just me. because this is kind of big. I can hold this up. It won't fit on the overhead. So this is an IntelliKey. So this is a accessibility board. So this is like a touch screen, touchpad. It's not a screen. Probably resistive underneath. This was like designed in like 2000s or 90s, and it uses USB. And you'd think like, oh, you have these overlays. I'll show the overlays real fast before we move on to the great search. But there's something really neat. Sorry, 1 second. So it comes with these overlays, and there's a protector to put aside. And like each overlay has like this is a mouse overlay, so you can see it's like you can move the mouse around, and then this is like a web browsing overlay. So it has like command and www and .com. So it's kind of like and it has a little bit of a bouncing. So this is like you can have quick access to common web browsing things. I remember we talked to Bill Binko about accessibility. He's like, if you can get people connected to a web browser, everything else is easy. Like the web browser, is the hardest part. But then from then on, you can do anything through a web browser. And this is just like a plain keyboard. And then what's really neat is when you insert this overlay into the slot. So there's a slot up here. So you put the overlay in, and it automatically knows which overlay, and it converts into this kind of keyboard. So, if I plug this in and I pressed on the D, it would be D. Whereas if I had like this calculator overlay, that D would be, 6. And when I pressed it, it would know that I was pressing 6. How does it know? I'm glad you asked. It's a very cute idea. So over here on the left, you see that there's this like black marking, and each overlay has the black marking, but they have it in a slightly different location. So, this one, it's closer. So like this one has like 1 marking here, and then this one has 3, and this one has 2, and then this has 2, but they're in like a different spot. So there's 3 photocells, and the photocells are looking for light or dark, like whether they can shine light through the paper. Or whether the light reflects back, and that's how it knows which overlay. And so it has like inside it has the brains to know like, oh, you put in the mouse overlay, I'm going to act like a mouse now, or like you put in the the calculator overlay, and I'm going to act like a calculator. So this is a really great accessibility board. It's like really durable. Of course, it's designed to handle spills and drops, and it's really nicely designed. There's only one issue, which is that the chip that this uses is called the Cypress Easy USB, which I like to tell people is the first chip I ever programmed for. When I got my first gig out of school at Mitsubishi Electric Research Lab for like a summer job, I programmed a Cypress Easy USB. And what's really interesting about this chip is, I guess at the time, flash memory was really expensive. And so what they did is the chip had RAM, but no flash. So the chip would connect to your computer and say, hi, I'm a new Easy USB chip. Give me your firmware. And the computer would transmit the firmware. Like it's kind of like a dynamic, it's like a bootloader, but it bootloads every single time. On Connect, it bootloads down the firmware, and then it restarts and runs that firmware. And so on one hand, this is kind of cool if you want to have like firmware that's constantly updating because the new driver has the new firmware. But the downside is it doesn't act like an HID keyboard. This isn't a standard keyboard because it needs to have that firmware downloaded to it. And so, on a computer, like a Windows computer, it's not too big of a deal because the company, they no longer make these, but they open source the driver, and so you can recompile it for Windows 10. But if you're on Android or Chrome or iOS, you're like shit of luck because there's no Cypress Easy USB firmware downloader for iOS, and there never will be because Cypress doesn't, they don't support the stuff anymore. But maybe with this USB Feather wing, sorry, this USB Feather, we would plug in the USB from the Cypress into here, and then the RP2040 would download the firmware into it, and then it would just translate, it would do that beginning part where it enumerates, downloads the firmware, and then disconnects, and then it would just pass through the keyboard part. So that will be kind of interesting to see whether we can get that working. There's existing code for the Teensy 36, but again, the Teensy 36 you can't get anymore. So future adventure. So I know I went on a little bit, but wanted to show some of the cool hardware. So Tack, who's the developer of Team USB, we sent him an IntelliKeys, and he got one of our USB host feathers, and working on it. And we sent him like a trace from a Beagle of this connecting, and there's existing code. So I'm pretty optimistic. And what's nice is that, this is one piece. It's, all assembled, ready to go. There's no like soldering, and with the built-in RP2040 ROM bootloader, it'll be very easy for people to update if like people make better firmware in Arduino for the USB host feather. So that's what we're doing over at my desk. You can tell it's extremely busy. So I thought we would go into the Great Search next.
Here we go.
Where in the world is that part I need? The Great Search with Digi-Key.
The Great Search brought to you by Digi-Key and Adafruit. Thank you, Digi-Key. Every single week, Ladyada uses her power of engineering to help you. Yes, you find the things on digikey.com. Ladyada, what are you looking for this week?
I'm glad you asked. So last week we talked about UFL to SMA adapters because we've got this RFM feather. And actually, let me pull up the design. 1 second. People can see how many folders I have on my computer. Okay, RFM. Okay, so let's go to the computer and I'll show off the design. Hold on, waiting for EagleCAD to load up. You can do it. EagleCAD. My computer. I replaced the fan on my computer, so it should be a little faster. I'm gonna slow down. Okay, so this is the RFM feather, and if y'all remember, last week we talked about this design. So this is a UFL connector. Let me put on the T-Dock-U so you can see. Hold on 1 second. There's so many layers. Okay, so this is the antenna using the UFL connector. UFL connectors allow quick attachment of to a tiny surface mount component, and then it would go to an SMA connector. And so last week on the Great Search, we talked about UFL to SMA adapters, SMA versus RP SMA. But now it's time to actually get an antenna. And I had, hold on, let me get my ginormous antenna because people like the good ginormous antennas. So I've got a couple antennas. Okay, so we got this ginormous antenna here, and then I've got attached to a UFL adapter. And what I like about this antenna is it's got this tilt and swivel. So like, it can be sticking up, or it can be tilted to the right, or it can be like tilted angularly, like 45 degrees. There's a little like clicker there. This is a antenna that is not tilt and swivel. It's just like, it goes on the top. Here's another tilt and swivel. This one is, I don't know what this is. I think this is a Wi-Fi antenna. So this is common. People get routers. You have a little Wi-Fi antenna sticking out. Again, you could have it be 45, 90 degrees, or straight out. And so, yeah, and this antenna, which is this enormous LoRa WAN antenna. I thought I'd show how to find antennas because you can get any kind of antenna on Digi-Key. They stock thousands and thousands of different ones. So maybe show people what to look for and some of the specifications when getting antennas. So let's go to Digi-Key. Okay, so let's look for, let's just type in antenna. Start with that. And then last week, remember, we did the coaxial cables or the RF accessories. So this is like, the image even is the thing that we want. We're like, yeah, I want a UFL to SMA or RP SMA adapter, but we want a RF antenna. So let's look for a single band, and we're going to look for a antenna. Okay, so hold on, active as well. So let's start with that. And then there's like so many specifications to look for, but the first thing we want to do is like, okay, we want the frequency band. So we're going to be finding an antenna that's used for LoRa or packet radio in the 915 megahertz ISM band. And that's in the US. In Japan, I think it's 868. And in parts of Europe, it's 433. Very similar, but let's just do 900 megahertz for us. So there's a couple of there's a couple of places actually where you can do the frequency. You can do the center, the frequency group, but I actually like frequency range because I can get, the tighter the range, usually like I'm generalizing a lot here because again, there's thousands of antennas, but in general, you want kind of like a tight range around 900, so maybe like 850 to 950 megahertz. So let's go down here. Okay. So a lot of options. So like I said, if you're in Japan, you might want 868. Let's kind of like just pick out a bunch that go from like about 870 and are at least 915, 920, wait, 960, 950, 925. Because it's, you don't want to be too specific. You want to have a range of options. 915. There's a lot. And I'm just option clicking all of these. And 900. Keep going, keep going, keep going. Okay, and now we're actually kind of getting to the end because this is past 9:15. Okay, so let's apply. And let's also only look for ones that are in stock right now. Okay, so there's a lot of options. So there's actually some antennas that already have a UFL connector. And like these are actually pretty good. Like if it's inside of an enclosure, again, this isn't weatherproof, but inside an enclosure, this is a perfectly good antenna. So a couple of those. This is like a whip antenna. Some of these are like pretty huge. It's like a metal gigantic antenna. You're gonna have some high gain antennas. What we want, and some surface mount antennas, what we want is and this is called a whip antenna, because you can whip it through the air, I guess, I don't know. And it's like a tilt swivel whip. So go to whip and we'll whip, tilt, and swivel. There are other antennas. The basic trade-offs you're going to get with antennas, without going into 5 years of antenna education, which I don't have, is there's directionality and the matchingness of the gain. So directionality is actually called the gain of the antenna. Now, I just want to warn people, because if you're like an analog engineer, you'll be like, oh, the gain of a circuit is how much it amplifies. These antennas are not active antennas. Unless you're purchasing an active antenna, the gain isn't like, it doesn't give you more. It just means how much more directional it is. So if you're doing a project where you're trying to, you have an antenna and you're pointing it at like the moon, or you're pointing it at another building, or you're pointing it at, a warehouse or something, and you want to transfer data back and forth, you want a high gain antenna because you want to be able to reach that just in that one direction. So it's high gain. If you are just trying to like radiate and get data from all over the place because you have like a mesh network, or you don't know where the nodes are, or you're doing like a LoRa setup where your nodes could be traveling all around, you want a low gain antenna. And the lowest gain is 1 because it's like a unit circle. And then the matchingness of the antenna is the vswr, and it's like the something virtual standing wave ratio, I think. I don't remember what the V stands for. Basically, you want it as low as possible. The lower the number, and basically you're going to get like 2 or less. That's normal. Is how efficient the antenna is at converting the electrical into RF energy. I can't get into a huge antenna tutorial right now. There's lots of good videos online on YouTube. Okay, so let's pick something with like a VSWR of 2 or less. Again, that's considered good. Other than that, in general, and then the gain. Remember, the gain is how directional it is. It's not how much more power you're getting. And then we have a lot of good options. So I do like, there's these really long ones and there's short ones. A lot of options here actually, which is kind of good. This one's nice. I kind of want like a huge one, which would be kind of cool. So, I could do by price. Can see what's going on here. This one's kind of short. This one is like this length. This one is so long, but this one looks good. I think this one is kind of the nice one because I want like a nice big antenna, because what I'm going to do is I'm going to use this antenna to do range testing. I want to see like how far can we go with this LoRa or RFM packet radio. So this one is my pick, the ANT916OCLG, and this is by Lynx. And I've been using Lynx antennas since like college, and they've always been really good. They're very reliable, and they've got excellent data sheets. which tell you like they'll give you the VSWR and they'll give you specifications, and they're very reliable. So I think this is gonna be my pick. $10.
That's a great search.
That's a great search.
Where in the world is that part I need? The great search with Digi-Key.
And that's our show for tonight. We got a lot going on, so we're gonna make this super fast, half an hour or so. We'll see everybody all throughout the week. Lots of stuff. We've been posting up tons of videos. It is a hardware bonanza. Join in, join up, share, and we'll see you later on in the week.
All right.
Bye, everybody.
Bye, everybody.